Day 3 is called validation. All right, so we studied two different types of statistical inference so far. The first one was confidence intervals, and the second one was significance testing. And these are really good mathematical techniques, algorithms, but we have to remember that there is more that goes into whether or not we can make conclusions. One is how your sample is taken, right? So when we did our sampling unit, we learned that the best types of samples are what types? Random, good. Random samples are the best types. And so if you just like ask your friends and then you try to do a significance test, that significance test might not be valid. Then we learned about sample size. If you just ask a few people, your sample is going to be much less valid than if you ask 100 people or 1,000 people. And we also learned about bias, like non-response bias, which is when some people decide not to answer your poll, or response bias when they answer incorrectly. We have some other as well. So these are all things that we've learned about that you have to consider in conjunction with our mathematical algorithms. So significance testing can't prove anything. It just measures the strength of the evidence. So it doesn't mean that your null hypothesis is definitely true or definitely false. It just tells you how likely it is that your hypothesis is true or false. All right, so remember we did a problem about flipping a coin and we were trying to figure out if that coin was fair. And if you don't get heads 50% of the time, or even close to 50% of the time, there are a few other reasons it could be. One could be you were just unlucky that time. Remember on the normal curve has those small sections on the side, which are those extreme possibilities, and they do happen. They're part of the curve. You didn't have enough trials. Your sample size was too small. If you only flip a coin 10 times, you could very well get 7 heads, 8 heads, 2 heads, not close to 50% heads. Or there could be a problem with your coin. Maybe most coins are fair, but there's something wrong with your coin. There are lots of other reasons too, but remember that you're always going to consider these as well. All right, so here's a new question. A television news program conducted a call-in poll about a proposed city ban on handgun ownership. Of the 2,372 calls received, 1,921 opposed the ban. The station makes the following statement. 81% of the Channel 13 Pulse poll sample opposed the ban. We can be 95% confident that our results are an accurate reflection of the population of the city, plus or minus 1.6%. So the first thing I'm going to have you guys do is calculate the standard deviation so you can see if their confidence interval is correct. Okay, so we calculated the standard deviation. We got the standard deviation is 0.008, which is 0.8%. And we know confidence intervals are plus or minus 2 times the standard deviation. So we got 1.6%. So we did get the same math as them. But the next question is, why is their conclusion not correct? Raise your hand if you can share a reason why their conclusion might not be correct. You can think back to slide 3 when we went over some things that you have to think about. I see 1 hand, 2 hands. Three hands. Kenneth, what are you thinking?
Oh, because they didn't poll the whole city, they just had people call in.
Okay. So they definitely could have gotten a better answer if they had polled the entire city. If you want to be sure, you could do that. Kyle, did you have something different?
I was going to say that it could be obviously political parties tend to have their respective news stations and news channels, so it could be one that favors a certain party.
Yeah. In fact, I think almost every news channel right now leans one way or the other, left or right. And so they may have differing opinions based on which channel it is that they're watching. Ireland.
I was gonna say something similar, like maybe only a certain type of the population tunes into this television program.
Yeah, excellent. What kind of sample could they do then instead of a voluntary response sample?
Random.
Yeah. So if they switch to a simple random sample, then they could get a better idea of what the whole city wants, right? Okay. All right, so here's a new question. I'm going to read the new question to you. Taking an antidepressant medication appears to double smokers' chances of kicking the habit, a study found. The newly published study was conducted on 615 volunteers who wanted to give up smoking and were not outwardly depressed. They took either Zyban or dummy pills for 6 weeks. A year later, 23% of those given Zyban were still off cigarettes compared to 12% of those in a comparison group. So 23% compared to 12%. All right, so the first one is, can we conclude that Zyban causes people to quit smoking? Just go with your gut on that one. Raise your hand if you think, yes, we can conclude that Zyban causes people to quit smoking. Raise your hand if you think, no, we can't. Okay. And raise your hand if you want to share why you think no, because I didn't see anybody say yes. Go ahead,
There's
Kevin.
a lot of different factors to quitting smoking. Like they could have had better family relations that help them quit smoking versus like just taking a Zyban pill.
Sure. There could have been lurking variables. Who else has something to share about that? Okay. Yes, Ireland.
If in this scenario it's like more of like an addiction, you need more than just like a medication to stop an addiction.
Okay.
There has to be more outside factors.
Okay. So they might need to combine the pill with another therapy. Okay. Anybody else? Okay, good. So this is pretty convincing evidence mathematically. I looked at the standard deviation, and I think I've lost it now, but it was really low. The standard deviation was really low, so we would not expect a variation this large usually. But yeah, there are more things that we could do to make this a better study. Based on their findings, what advice would you give the researchers? What could we do to be more convincing, even mathematically? Kyle?
Always have more trials.
Always have more trials, right. So when you are doing an experiment, we do expect 95% of the data to be within 2 standard deviations. But what about the other 5%? Yeah, those could actually be not what you expect. So this could be just a fluke. You know, it could be one of those studies that are at the margins of your normal curve. But maybe it's like right there in the middle. We don't know. So more trials could definitely help. Anybody have a different suggestion? So along the lines of more trials, your trials could just be larger. You could ask more people, and that could be more convincing too. All right, and I think that's our last slide. Yeah. So your activity today is going to review the day 1 and day 2 concepts, and also just incorporate some of these ideas from day 3 about being careful about not relying too much on just the mathematics there. So let's get started on that one. And if you did not finish the Women's History Month one, you can do that as well.